This lesson is on section 10.1, titled Linear and Nonlinear Functions. So the definition of a nonlinear function is pretty much the opposite of what we talked about in chapter 9, which are functions that do not have constant rate of changes. So all in chapter 9, we are dealing with constant rate of change for all of our functions. Nonlinear is the exact opposite. So there's no pattern, there's no constant rate of change. So the first example says to determine whether each table represents a linear, that means there's a constant rate of change or constant pattern, or a non-linear, where there's no pattern. And then we have to say why. Okay, so let's see if there's a pattern. Well, it looks like every time here, looks like I'm going up to here, going up to here, going up to here. Okay, let's see. It looks like I'm going down 15, down 15, down 15. Because we see a pattern on both sides, you know it's going up 2 and going down 15. Because we see both patterns, it's linear. Okay, so if you see a pattern, you know it's linear. So let's look at number 2. Okay, so it looks like it's going up 3, up 3, up 3. So far it looks like it's linear, but let's just double check. So it looks like it's going up 15. Oh, right away I know that's a lot more than 15, and I know this is a lot more than 15. So right away, because there's no pattern, it's not 15. I'm going to say right away, I don't even have to do the math, I'm going to say it's non-linear. Make it as easy as possible for you. Right when you know, you can stop. But it's good for you to be able to double check on both of them, just in case your math is a little bit off on one. So if it's linear, there's a pattern. If it's non-linear, it doesn't have a pattern. No constant relationship. Next example, we have to determine whether each graph represents a linear or non-linear function. Pretty nice about this word, linear, has the word line in it. If there's a straight line in your graph, you know it's linear. If it's not a straight line, it's not linear. Easy as that. Just think about that. If there's a curve, then it's not linear. If it's a straight line, think of the word linear line, it is linear. So let's look. Here, number 1, it looks like, this one's totally curving. There's not a straight line. It's a curve. So we're going to say it's nonlinear. And oppositely, this is a straight line. There's no curve, so we're going to say it's linear. It's as easy as that. Think of linear line. Easy as that. All right, let's look at the last examples. This is determine whether each graph represents a linear, so a straight line, or non-linear, like a curve function. Okay, so let's go back. We know the formula, slope-intercept form that we learned in the last chapter. We said y equals mx plus b. So if we can if our equation looks like y equals our slope and our y-intercept, if we can get it into this form, we know it's linear. If we can't get it into this slope-intercept form, then it's going to be nonlinear. So let's look here. So y equals x plus 4. Well, we know that if there's no number in front of that x, we can just say y equals 1x plus 4. That is in slope-intercept form. It's in the mx plus b form, so we can say it's linear. Okay, so then we have y equals 6 divided by x. Now, right away, we've got that division sign. There's no way we're going to be able to make it into this form, so we're going to say it's nonlinear. So, again, just to recap, if you can get it into this equation, y equals mx plus b, it's linear. If you cannot, like in number 2, it's going to be nonlinear. So biggest thing, hopefully, that you can take out of this, linear means line, or that y equals mx plus b. And, a nonlinear equation doesn't have any pattern. Linear equation does. That brings me to the end of this lesson. Thanks for watching.